My name is Saiteja from ECB section. Today my topic in control system is parallel control for continuous time linear system, a case study. Introduction. Over the past decades, with the rapid development of science and technology, control control theory and technology are playing increasingly important roles. The development of control theory has generally gone through these stages: classic control theorem, modern control theorem, and intelligent control theorem. Based on frequency domain analysis, the classic control theorem mainly solves the control problems of a single input signal output linear time invariant system based on a state space description. The modern control mainly solves the control problem of multi input and multi output systems. Comparing this with the control system, the modern control theorem is more suitable for the analysis of time varying nonlinear system. A typical modern control theory includes optimal control, adaptive control, and also so on, with the interference of complexity and nonlinearity. Parallel control theorem, proposed by Wang, is an effective method to obtain the control laws of the control system. The basic structure of parallel system is shown. The basic idea of control is expanded the practical problem in a virtual space. Then the controls task can realize by means of virtual reality interaction. To be specific, parallel role control application, parallel role application as shown in the figure, where artificial systems are used for modeling the physical system. Computational experiments are used for analysis, evaluation, and learning, and parallel executions are utilized for control management. Optimization. Compare with the parallel system. A similar concept is digital twins. The parallel systems and digital twins manage a control system which are difficult to analyze with mathematical models by analyzing the virtual system coordinates corresponding to the physical system. However, there were some difference between parallel systems or digital twins. The research objects of digital twins are cyber physical systems which are composed of information, space, and physical information. And the parallel system mainly focus on a cyber physical social system, which refers to the deep integration of social networks, information, resources, and space. In addition to the research object, there are certain differences in the core ideas, frameworks, mathematical description, implementation method, and so on. The domain state of articles of parallel control management for CPSS. The detailed description can be found in this is the ACP, Artificial Society plus Computational Experiment plus Parallel Execution. Physical system, artificial system, and the management control and the it is pointed out the parallel execution is an important and distinction step to guarantee the performance of the control system. This basic block diagram of parallel execution, that parallel execution is established based on the parallel system theory. Based on the parallel execution between artificial system and physical system, we can convert passive computer simulation to the active artificial system and give full play to the role of artificial system in management and control of the system. Problems for formulation. In this session, the design idea of parallel controls are the presented. First, the basic structure of the parallel control is introduced and compromises between parallel control and the traditional control of illiterate, where the advantages of parallel control are emphasized. Second, the problem formulation of parallel per continuous time linear system are represented. Basic structure of parallel control. In this subsection, the basic structure of parallel section is introduced considering the following: x equal to f of x comma u, where x belongs to r to the power of n in the n dimensional state vector, u belongs to r power m is the m dimensional control vector, and the f of x comma u is a system of functions, and a new parallel control method is established. The structure of a parallel control is figure shows, and the parallel control can be expressed in the u equal to g of x comma u. The feedback mechanism. The input and control manager and parallel system and gives us output and using feedback mechanism. And the variation of the control is especially depending with the state and the current control. Numerical analysis. In this session, the two stimulations are employed to evaluate the effectiveness of the proposed method. In the first example, we consider the following linearized model of power system. X as given and showing figure, it is easy to divide the system. 45 is controllable. The desirable plots are -1, -1, -2, -2 and -3. We have the characteristic polarization. X plus 1 whole square plus x plus 2 whole square into x plus 3 whole. According to the algorithm, we can obtain that C equal to the D equal to 8.4655, and the parallel control can be expressed as the showing in the figure. The initial state and control law are x naught equal to 0, 0.100 and u naught equal to 0.1 respectively. They can be obtained stimulation results for the transaction of the control, and we are shown in figure of 5 and 6 as shown in the figure 5 and 6. The trajectory of the system as shown in the figure 5 and the trajectory of control as shown in the figure 6. And this is the system state in example 1 of system state with the respective of time. The blue line is x1 and the x2, x3 and x4. The poles of controllable subsystems are 1, 2 and the poles of uncontrolled system is -1. The desired poles of are -1, -2, -1, -2. According to the algorithm, we can obtain the C and D, where C is the arbitrary constant and the parallel control can be obtained as mu u equal to C minus 30, C minus 40, x minus 8u. The initial state and control law are x naught equal to 0.511 and u naught equal to 0.1 respectively. Taking C equal to -3, we can obtain the stimulation results as figure 7 and 8. The trajectories of system state as shown in Figure 7. The trajectory of control line shown is figure 8. The correctness of the proposed control method can be demonstrated.